All right, this is part two where we're going to be looking at the 30, 60, 90 special right triangle. So out of the two special right triangles that we have, the 45, 45, 90 and the 30, 60, 90, this one is going to be the more challenging one to work with. So when we're looking at a 30, 60, 90, the first thing we want to make sure that we understand is that you have a 30 degrees and a 60 degrees, yes, but across the 30 degrees, you're going to see that this is the shorter leg of the triangle. Across the 60 degrees is the longer leg, and then of course that third side is the hypotenuse. Now, the way that we're going to label the shorter leg is we're going to label that as A. The longer leg is, we'll go ahead and label this here. The longer leg is going to be A square root of 3. So what this tells us is the relationship between the longer leg and the shorter leg is that the longer leg is the shorter leg's length multiplied by the square root of 3. And the hypotenuse here is going to be 2a. So this is 2a, which tells us if the hypotenuse is 2a, it's going to be 2 times the length of the shorter leg. Now, this part's important to make sure that we understand so that we're correctly labeling the examples that we have coming up. Across the 30 is a, so kind of looking at that with an arrow. And across the 60 is a square root of 3. And your hypotenuse is across the 90, that is 2a. Right? So just make sure that we understand how to label this because this could cause some issues if we label incorrectly. So what we have here off to the right is a note of what we mentioned there in the beginning, that the shorter leg is always opposite the 30-degree angle and the longer leg is always opposite the 60-degree angle. Right? So some things to think about here. So as we look at this example, all I'm going to do really quickly is just draw out our 30, 60, 90 off to the side. So here's 30, here's 60, and here's 90. So here's our a, here's a square root of 3, and here's 2a. So for reference. Now, looking at example 4, we have the following triangle. Whether they gave us 60 degrees, well, this is going to have to be 30 degrees to complete the 180 that we have inside the triangle with the 3 angles. So now we get to labeling. If we're going to label, then we're going to start with the side that is across the 30, this is a. The side that is across the 60, this is a square root of 3. And then the hypotenuse, which is across the 90, is 2a. Right? So I always recommend labeling. Right? It doesn't take a super long time. And then we can essentially do the same thing we did with the 45, 45, 90. We're going to identify the side that they gave us. They gave us 17, and that represents our A side. So we can build an equation that says that. Right now, we know that my side A is going to be equal to 17, right? Now, we build equations with the other sides that we're asked to find. Our side that is X, well, that is our 2A side. So this is 2 times A. Well, we know A is 17, so plug it in. This would be 2 times 17, which gives us an X value of 34. So we know X is 34. And then we repeat that process for finding the value of Y. If Y is our A square root of 3 side, well, plug in our value for A. A is 17. So we're going to plug in 17 here, and then times square root of 3. There's nothing that we can do to simplify that, so we're just going to leave it as 17 square root of 3 for our value for Y. Right? So I said this in the previous video, but I'm going to say it again. With these special right triangles, A is going to be your best friend. Once you find A, it's just a matter of plugging things in. So let's go ahead and look at another example. Let's look at example 5. Looking at example 5 here, we have the 60-degree angle here, the 90, and then up top here is going to be our 30. Right? Now, if we're going to go through the process of labeling, start with the 30. Across the 30, this is A. Across the 60, this is A square root of 3, and the hypotenuse is 2A. Now, identifying what side length was given to us, we have our 5 root 3 representing the A square root of 3 side. So if we build an equation from that, we can say here that our A square root of 3 side is equal to 5 square root of 3. Remember, A is your best friend. We want to always focus our attention on finding A. What does A equal? So we have an equation with A. We're going to solve for A. So we have A times the square root of 3. How do I cancel multiplying by the square root of 3? Well, to do the opposite would be to divide. That's how we cancel. So divide both sides by the square root of 3. This cancels, and well, these square root of 3's also cancel. So this tells us here that A is equal to 5. Well, if a is equal to 5, then we can start to find our answers here. X, this side length of x is represented by the side of 2a. So this would be x is equal to 2 times the value of a, which we just found to be 5. So 2 times 5 gives us 10. And then our y value here, let's just box it. Our y value now is just simply a, which we already determined that a was 5. So 5. All right. So again, some of these problems look pretty obvious. Just we want to take the time to practice building these equations so that when we do get to the more challenging questions, we're not as troubled by them. Now, looking at our example 6. So example 6, they gave us the 90, they gave us the 30, right? And we're just doing mental math here. The angle that's missing here to complete the triangle angle sum theorem is 60 degrees. So again, label your triangle. We said across the 30 is a, across the 60 is a square root of 3, and across the 90 the hypotenuse is 2a. So this time they gave you the hypotenuse, which is the 2a side. So we build our equation based off of that. 2a is equal to 32. Now, we focus our attention on finding a because a is our best friend, so divide by 2. We get a is equal to 16. So if a is equal to 16, well, we already know what x is. X is just equal to a. So x is equal to a, which is 16. So x is equal to 16. And then our value for y, well, y is equal to a square root of 3. So take your a value and plug it in. So we get y is equal to 16 root 3. And there we have it. So what we'll see in these examples is that the numbers and the values that we deal with become a lot more complicated. So if we look at the next example, example 8 says find the value of x and y. Well, now we're looking at a 30, 60, 90. They gave us the 60, the 90. That means we're looking at 30 degrees here. Now if we're going to labeling our sides, across the 30 is a, across the 60 is a square root of 3. And across the 90, your hypotenuse is 2a, right? That was the relationship of the sides in a 30, 60, 90. Now, the side that they gave us was the 2a side. So 2a is our 8 square root of 5. So build our equation based off of that. 2a is equal to 8 root 5. And we want to solve for a, so we are going to divide by 2. Doing so gives us a is equal to, well, 8 divided by 2 is 4, so this becomes 4 root 5. So there's our value for a, which that gives us the length of y. If y is equal to a, then y is just simply equal to our 4 root 5. What's left is for us to find x. Well, x is equal to our a square root of 3 side. If this is our value for a, we're going to plug it in. Plugging that in, we have x is equal to, you write that underneath, x is equal to our a value, which is 4 root 5, multiplied by the square root of 3. Now when we're multiplying square roots or radicals, we multiply the numbers in front together. Now there's technically a 1 here, it's just not written, so 4 times 1 is 4, and then square root of 5 times square root of 3 is square root of 15. So x is equal to 4 square root of 15. Then you would normally check, can this be simplified? The square root of 15 cannot be simplified, so there is our answer. Right? So some slightly more difficult, but some slightly more challenging problems is what I meant to say, is what we're looking at in this video. Right? So let's practice with a few more. Number 9, find the value of x and y. Again, we're dealing with the 30, 60, 90. Now, here's our 30, here's the 90, here is the 60. Now, labeling our triangle across the 30, this is a. Across the 60, this is a square root of 3. And then across the 90 is 2a. Let me actually write that a little neater. It's hard to see. Square root of 3. And then this is 2a. There we go. Now, the side that they gave us is the side length of 12, which is our a square root of 3 side. So, build our equation based off of that. A square root of 3, that side is equal to 12. And we want to find the value of a. So, solving for a, we are going to divide both sides by square root of 3. We end up with a is equal to 12 over the square root of 3. and we end up with a situation like we did in the very beginning of this video. We cannot have a square root in the denominator. So if we want to fix this, we're going to rationalize by multiplying the top and the bottom by that same square root, which is the square root of 3. Multiplying straight across the top, you get 12 root 3. Straight across the bottom, the square root of 3 times the square root of 3 is the square root of 9. And then that simplifies to 12 root 3 over square root of 9 is just 3. Right? If you understand this step right here, you can just go immediately from here to here. That's completely fine. Now, we can still simplify even further. 12 over 3 simplifies to just 4. So this is 4 root 3. So our value for a is 4 root 3. And now that we know a, we can find the rest of our missing side lengths. Now, x is equal to 2a. So x is going to be equal to 2 times our a value, which we got 4 root 3. So 2 times 4 root 3, that gives us x is equal to 8 square root of 3. And our value for y, well, y is just equal to a. So y is just going to be equal to our 4 root 3. And there we have it. All right, this video is going to be the last part of our notes on special right triangles. This video is going to focus on the word problems that we can potentially run into that involve using special rights. So let's jump into this looking at number 11. Number 11 says an equilateral triangle has a perimeter of 18 centimeters. Find the length of the altitude. Well, if we are looking at an equilateral triangle, it'd be helpful for us to draw this out. Let's draw out an equilateral triangle here. Now, looking at this equilateral triangle, we know that the perimeter is 18 centimeters. Well, if this triangle is equilateral, we know two things. We know that all three sides are congruent, and we know that all three angles are congruent. Now, if all three angles are congruent, that means that every angle is going to measure 60 degrees. Now, they did also tell us that the triangle has a perimeter of 18 centimeters. Well, if all three sides add up to 18, well, we know all three sides are congruent. We have 3 of those sides. So 18 divided by 3 would tell us the length of each side is 6. So every side length is 6. Now, they want us to find the length of the altitude. Well, if I draw in an altitude here, remember that an altitude goes from the vertex to the opposite side, creating a 90-degree angle. Now, anytime, this part is extremely important. I'm not going to write it out, but I am going to talk about it. Whenever you drop in a altitude in an equilateral triangle, what that altitude does is it bisects that angle, right? So this 60 degrees has now been bisected, making it 30 degrees and 30 degrees. Now, on top of this angle being bisected, it actually also bisects this bottom side here. So if this whole bottom side is 6, then when we bisect it, that means we get 3 and 3, right? So again, anytime you drop in an altitude in an equilateral triangle, it's going to bisect the angle and bisect the side. Now, this is true for equilateral triangles and for isosceles triangles. So I know I'm repeating myself a lot. It's just to make sure that you remember. So summarizing that, if you drop an altitude in an equilateral triangle or in an isosceles triangle at the vertex angle, then it's going to bisect that angle and the side that it connects to. So with that in mind, the question asked us find the length of the altitude. The altitude is this blue segment here, which we're going to call x. Now, looking at the figure that we drew here, looking at what we have is we actually have what we have just been working with. We have a 30, 60, 90 special right triangle. Now, all I'm going to do now is just separate it off to the side just so that it's a little bit easier to look at. So this is a 90-degree angle. At the top is our 30 degrees. Here's our 60 degrees. And then we know that the hypotenuse here is 6. And we are asked to find x. And then we also know this bottom side here is 3. Right? So in our 30, 60, 90, remember across the 30 is a, across the 60 is a root 3, and the hypotenuse here is 2a. So we actually just got the best case scenario. Best case scenario is that they give you a. They gave us a. A is equal to 3. If A is equal to 3, then our altitude, which is x, well, x is equal to a root 3, so just plug it in. A is 3. That means x is equal to 3 root 3. And the question asked, find the length of the altitude. Well, I decided to call it x. The altitude, while it is x, our altitude, sure it's x, but it is 3 root 3. And this altitude happens to have units because we're talking about length. Looking at the question, we're talking about centimeters. So our answer here is the altitude is equal to 3 root 3 centimeters. Okay?